want from New Orleans. Came upon a tornado, so loud in the sky. Are we around all day with the moonstick in my eye? Hey, all you young girls, wherever you're at,
Morning, everyone. That's what I'm looking for. Still a bit early. Let's have another one. Sorry. I usually I'm better prepared. Was having technical difficulties this morning. Can you give me what number 2 is? That's fine, Lauren. You can attend, no problem. Yamin, please give us what number 2 is. For those of you interested, what were we listening to this morning? Last time we were listening to Tragically Hip. And in the song, there was a part where Gord says, "Get Ry Cooter to sing my eulogy." So who's Ry Cooter? What we just heard was Captain Beefheart. Where Ry Cooter was playing the guitar and really produced the album, if you will. They had been invited to Monterey, to the Monterey Pop Festival, but Ry left the band before then and couldn't be replaced, so they never made it. The slide guitarist, exactly, right? I mean, I didn't really know of him before the song, and turns out Rolling Stone magazine at some point ranked him the 8th best guitarist who ever lived. Well, Ry Cooter was not the one singing. So in Captain Beefheart, he's not the singer. Yeah, exactly. He also orchestrated the entire Buena Vista Social Club renaissance, if you will. Who did they rank first? I think it's the obvious choice, Jimi Hendrix. Yeah, I mean, you say number 2 on page 102, but I don't have the book with me. Can you give me what the question is asking for? All right, but anyways, while Yamin is... So, I mean, I'll invite you to have a look at that, have a listen. You know, I mean, we heard a few things. There's an obvious kind of animals feel to it. Also, other songs sound quite a lot like Frank Zappa. And it's my understanding that Captain Beefheart and Frank Zappa were close at some point. All right, I mean, then maybe I'll bring it next time. I'll bring the book next time. We can discuss it then. All right, we're asked to evaluate the limit by justifying every step. This is not something we're going to do for long, but, you know, I mean, it's important to understand what's happening. And, you know, we're referring to these limit laws that we saw last time. And by these limit laws, the limit of a sum is the sum of the limits. I am using the 9th edition. So limit of the sum is the sum of the limits. So 2x cubed plus limit as x goes to negative 3 of 6x squared plus limit as x goes to negative 3 of negative 9. And then we saw the limit of a product is the product of the limits, assuming the limits exist. So this is limit of 2 times limit of x cubed plus limit of 6 times the limit of x squared. And well, let me leave that as is for one step. And then we saw that the limit of a constant was just that constant. In fact, we proved that. So the limit of 2 as x goes to negative 3 is going to be 2. And we saw the limit of a power is the power of the limits. So this is limit as x goes to minus 3 of x all cubed. Similarly, the limit of 6 is 6. And the limit of x squared is going to be the limit of x all squared. And finally, the limit of negative 9 is negative 9. And we also saw that the limit of x as x goes to a was a. So this is 2 times negative 3 cubed. This is negative 3 squared. And this is going to be 27 times 2 is negative 54. Negative 54. 9 times 6 is 54 minus 9. So the whole thing is minus 9. Can you just use the difference law, right? So minus the limit of 9, that would be fine as well. Another option is noticing that this is just a polynomial, right? It's just a polynomial. So the limit as x goes to negative 3 is just a polynomial evaluated at negative 3. And that would have brought you to this step immediately. But it's all good. Same answer in the end anyways. Shall we do one more? Right here we're justifying every single step. Again, not something, something we're going to stop doing right after this next example, but still an important exercise to get an understanding of what's really happening with limits. So somebody was asking for a product of two polynomials. We don't have that exactly, but it's almost that, right? So I think that would be good enough. We're looking for the limit of this function, right? So a limit, it's a behavior. How does this function behave for values close to 3? Well, you've noticed it's a product. So by one of the properties, the limit of a product is the product of the limits, assuming the two limits exist. So here the ends will justify the means. Let's not call it the product law, although there wouldn't be anything wrong with that. But for those who've done some